Welcome! In today's episode we are going to discuss everything about air conditioners, how they work, history of air conditioning, how to choose an air conditioner, how to optimize its performance and what are their adverse effects on global warming. So how do air conditioners work, and what is the effect on the environment? As record heat waves boost demand for cooling, air conditioning becomes vital, but with a steep environmental cost. Heat waves all over the world are becoming longer and more intense, and the need for cooling is rising fast, putting strain not just on power bills but on electricity grids and the planet. With last year the hottest year on record and this year not far behind, air conditioning is no longer a luxury for many, it's a lifeline. We break down how air conditioners work, tracing the history of cooling, and offering practical tips on protecting your AC and reducing energy costs. How does air conditioning actually work? Air conditioners cool indoor spaces by moving heat from inside your home to the outside using a chemical fluid called a refrigerant. The process starts when the indoor unit draws in warm air from the room and passes it over evaporator coils filled with cold, low-pressure liquid refrigerant. As the air moves across the coils, the refrigerant absorbs the heat and evaporates into a gas, cooling the air in the process. A fan then blows the cooled air back into the room. The now warm refrigerant travels to the outdoor unit, where a compressor increases its pressure and temperature. In the condenser coils, the refrigerant releases heat to the outside air, turning back into a liquid. The cycle then repeats. How long have air conditioners been around? In 1820, British scientist Michael Faraday discovered that compressing and evaporating ammonia could chill air. It was an early breakthrough that laid the foundation for modern refrigeration and cooling systems. In the 1830s, American physician John Gorrie took a practical approach to the idea. He built a machine in Florida which created ice and used it to cool hospital rooms, aiming to treat patients suffering from tropical diseases. The modern era of air conditioning began in 1902, when Willis Carrier, an American engineer, designed a system to control humidity and temperature at a New York printing press. Though intended to remove humidity, which causes paper to expand and contract and can change ink colors, Carrier's invention is considered the first true air conditioner. By 1914, the first residential air conditioner was installed in a Minneapolis mansion. It was huge, roughly the size of an entire room, and far from affordable for the average household. In 1931, engineers H. H. Schultz and J. Q. Sherman developed the first window-mounted unit, making cooling more accessible for individual rooms. This innovation paved the way for household adoption in urban areas. The 1940s and 1950s saw a rapid expansion in air conditioning use. After World War II, economic growth, mass production and suburban housing booms brought AC into homes and offices. During this time, Freon, a chlorofluorocarbon, or CFC, replaced toxic refrigerants like ammonia and propane, making systems safer, more compact and easier to install. The mini-split system was first developed in Japan in the late 1950s as a more efficient alternative to bulky window units and centralized vac systems. Its key innovation was a ductless design, which delivers air directly from an outdoor compressor to an indoor air handler, minimizing energy loss typically caused by ductwork. By the 1970s and 1980s, mini-splits were being used across Asia and parts of Europe, and later expanded into North America. Their flexible installation and energy efficiency made them ideal for older buildings where retrofitting ducts was costly or impractical, as well as for homeowners seeking precise, room-by-room climate control. This is also when inverter technology, which adjusts the speed of the compressor to help save energy, was developed. In the 1990s, rising energy costs and growing environmental concerns led governments to adopt energy efficiency standards for cooling systems. In response, manufacturers introduced more efficient compressors, thermostats and system designs to reduce electricity consumption. During this period, the United States Clean Air Act was amended to phase out ozone-depleting chlorofluorocarbons, CFCs. Their replacement, hydrofluorocarbons, HFCs, like R134A, gained popularity. But while HFCs don't harm the ozone layer, they are potent greenhouse gases which contribute significantly to global warming. The 2000s brought a new wave of innovation, with air conditioners beginning to integrate digital controls, motion sensors, and smart thermostats. Wi-Fi connectivity allowed users to adjust temperature settings remotely, while automation made systems more adaptive and efficient. By the 2010s, concerns over global warming and the environmental effects of refrigerants triggered a transition away from hydrofluorocarbons, HFCs. Newer refrigerants like R32 and R290, propane, already being used in parts of Asia and Europe, marked a shift towards low-emission, climate-friendly cooling. How to choose the right air conditioner. Choosing the best-sized air conditioner is essential for keeping your home comfortable and your energy bills under control. Since an AC is a long-term investment, having the correct size can save you both money and hassle. A unit that is too small will struggle to cool a large room effectively, or may not cool it at all. On the other hand, an oversized AC may cool the space too quickly without removing enough humidity, leaving the room uncomfortably cold and damp. Air conditioners are rated in tons, a measure of how much heat they can remove in 1 hour. Choosing the right tonnage ensures your room cools efficiently without wasting energy. For a room size of 100 to 200 square feet, 1 ton is appropriate. For a room size of 200 to 400 square feet, 1.5 ton is appropriate. For a room size of 400 to 500 square feet, 2 ton is appropriate. For a room size of 500 to 700 square feet, 2.5 ton is appropriate. For a room size of 700 to 900 square feet, 3 ton is appropriate. Other factors to consider? Sunlight. Sun-exposed rooms may need higher tonnage. Ceiling height. Higher ceilings mean more air to cool. Number of occupants. More people generate more heat. Appliances. Rooms with computers, ovens, or TVs may require extra cooling. How to protect your air conditioner. Air conditioners work hard during the hottest months, and proper care can prevent breakdowns, lower energy use, and extend the life of the system. Here's how to keep yours running smoothly. Don't set the thermostat too low. Keep the air filters clean. Give it a break. Don't keep turning it on and off. Keep the outer unit in the shade. How to reduce air conditioner energy use. Install and set a programmable thermostat. Using a ceiling fan can allow you to raise the thermostat temperature by about 4 degrees. Seal cracks and openings to prevent warm air leaking into the room. Avoid using heat appliances. Draw the curtains to reduce the sun's heat. Use exhaust fans to expel heat when using kitchen cookers or having warm baths. How much do air conditioners contribute to global warming? While air conditioners provide much-needed relief from extreme heat, they also contribute significantly to the very problem they're trying to solve, global warming. According to the International Energy Agency, IEA, space cooling technology, which includes air conditioners and electric fans, consumed about 2,100 terawatt-hours, TWh, of electricity globally in 2022. That's about 7% of total global electricity use, which was roughly 29,000 terawatt-hours. When looking specifically at buildings, cooling accounts for nearly 20% of electricity consumption. This enormous energy demand comes with a climate cost. The IEA estimates that space cooling was responsible for about 1 billion tons of carbon dioxide emissions in 2022 from electricity use alone, about 2.7% of global carbon dioxide emissions from fossil fuels and industry. And that's only part of the picture. These numbers don't include the effect of refrigerants, powerful greenhouse gases used in many AC units, which further amplify the climate footprint of cooling. While air conditioning helps us to be comfortable in a world of rising heat each year, it also risks deepening the climate crisis unless cleaner energy and climate-friendly technologies are adopted. A global surge in air conditioning. Global warming and rapid urbanization are prompting a global surge in air conditioner use. Demand for cooling is rising fastest in tropical and subtropical regions, particularly in urban areas. Cities heat up faster than surrounding countryside areas because of the urban heat island effect caused by heat being trapped by asphalt and concrete. According to the IEA, by 2018, air conditioning was nearly universal in countries like Japan, the US, and South Korea. In contrast, ownership remained low in heat-exposed but lower-income nations such as India and South Africa, where access is limited despite intensifying heat waves. Countries with both hot climates and higher incomes, like Saudi Arabia, where 63% of households have an AC unit, and South Korea, 86%, have widespread adoption. Meanwhile, AC ownership in emerging economies such as Indonesia, 20%, and India, 13%, is expanding rapidly as cooling shifts from a luxury to a basic need. According to the International Energy Agency, as of 2018, nearly all households in countries like Japan, the United States, and South Korea had air conditioning. In contrast, in countries such as India and South Africa, despite frequent extreme heat, very few homes had access to cooling. Percentage of households equipped with AC in selected countries is as follows. For Japan, US, and South Korea it's 90%. For China and Saudi Arabia it's 60%. For Mexico and Brazil it's 15%. And for India it's mere 5%. Finally, how to build a homemade air cooler. If you don't own an air conditioner or are trying to save on energy costs, here are some steps you can follow to build your DIY cooler out of a styrofoam cooler, ice, and a fan. While this won't help with humidity, it can provide temporary relief during the hottest time of the day. With the aim to learn about a new thing every time and get 1% better, we are concluding today's episode. In the end, hope you find this episode quite informative and interesting. We are committed to make the world that we live in more and more meaningful for each one of you. Thank you.